Assalamu alaikum wa rahmatullahi wa barakatuh, dear grade 11 students, welcome again. And today, inshallah, we will be going through the chapter 2, basically starting from section 1 and going through the sections of chapter 2. So, starting in the chapter 2, as we said, if you remember in the beginning of chapter 1, we said the chapter one's title was talking about the one-dimensional motion, but today our topic, which is in chapter two, it's gonna be talking about two-dimensional motion, and that's a big difference that we have in between the two chapters, we can say, because in here we start to talk about two-dimensional motion, and to remind you of what was the dimensions, basically in chapter 1, we said each dimension is like either horizontal or vertical. So when we have them both in this chapter, we will be talking about both of them together. So we will have horizontal and vertical dimensions together in one motion. We are about to see how is that possible. But before we go in deep into that, let's see the topics of this chapter. So starting with section 1, it's basically introducing us to the vectors and what are they. Even though that we have mentioned them in chapter 1, there are more details that we can dive into, which we are going to do in this chapter. So these are the topics of each section. In section 2, it's more about the operations of vectors. So operation of vectors, as the name suggests, we will be having more than one vector, or like we will be doing operations on specific vectors and see what we can do with them. So that will be interesting, inshallah. Let's see how we can go on forward. Let me check. Yeah. So after that, we are about to get into projectile motion, which is something gonna be easy, inshallah, and not gonna take much time. Our main focus, to be honest, in this chapter is section 2, because section 2 is very necessary for the grade 12. It's mentioned in chapter 1, 2, 3, even 5 and 6 in grade 12 physics. So pay attention to that chapter and try to understand what it's talking about. So this video we are about to get into the section 1. The first thing in section 1, it's introducing for us what is a vector. So the first thing that we need to understand is the definition of the vector. Vector quantity is a physical quantity that has both magnitude and direction. Like what? Like the displacement, velocity, acceleration, which we already studied in chapter 1. Those were what? Vector quantities. So we are now trying to understand how to deal with them as vectors. Scalar quantities, on the other hand, is a physical quantity that has only a magnitude without direction. So to give you like a simple example about those two, displacement and distance. Distance is just the magnitude of the displacement, because displacement has both magnitude and direction. But we will be we will be looking into how to use displacement as a vector. There we only knew that it has magnitude and direction, but here we will be more worrying about like how we can represent the magnitude and direction aspects as a vector, which is like drawn as an arrow. We are about to see that. So more examples about them, scalars and vectors. Those are scalars and those are vectors. So you can see that distance and displacement, speed and velocity, mass and weight. Those three, the first three, they are very important because they are related. Yani all three of them are speaking of the same, let's say, type of quantity, but both describing it in a different way. Those are vectors which have directions and magnitudes, and those have only the magnitude of it. But force is also important. We will be focusing on the force only in the chapter 3, which is the Newton's formulas. We will be looking on how to use force as a vector. So it's important also. Now getting into vectors, we need to know their types. So what are the types that we will see? let's say. So the first type that we need to be familiar with, which is something that we already took in chapter 1, which is the one-dimensional vectors, which are either horizontal going to the right, which is positive, for example, displacement is positive in that case, or going to the left, which is negative, or vertical going up positively or going down negative. So these are like the one-dimensional vectors that we have, and the two-dimensional vectors, they are always going in between, like both horizontal and vertical at the same time, going between. So how we can describe that, like is it this way, is it that way, which angle that it has, as we said, angle. So to describe the direction of a resultant vector, or what is called two-dimensional vector, you will need an angle to describe the direction of it. I wish that is clear for you. So before we go to the next slide, there is something that is important, which is knowing what the resultant mean. Resultant vector is a resultant of two or more vectors that are called component vectors. So in that case of the two-dimensional vectors, we have a horizontal component, which is in here, and we have a vertical component in here. Those two components form this result, which is called resultant vector. So that I wish that this gives the meaning for you. Then this is very important and crucial for you as grade 11 student to memorize those definitions or like properties, sorry. The first property that we have, which is vectors can be moved parallel to themselves in a diagram. What does that mean? If I took multiple steps to go to somewhere, I'm taking multiple vectors. So let's see that in a graph. In that case, let me zoom in so that we can see it more clearly. In that case where I have this graph, I wanted to move from this initial position to that final position. But in order to get from here to here, which is my resultant vector, as you can see, I have to take those directions or sub-directions, which are called the components of that resultant. The resultant starting from here, ending at here. That's my let's say resultant displacement. But there is also like small vectors that are components. Those are called the component vectors. So the property is telling us that those vectors can be moved parallel to themselves. So if a vector is already a vertical vector, we can move it like this, right and left. We cannot change how it looks. We can just move it as it is. And those vectors, the horizontal ones, we can move them up and down to not change how they look. The shape of them will be stable, will be constant, but we only move them up or down, like either getting them after a step or before it. Let's see how is that possible. So as you can see in that case, you have moved it first vertically one step, then to the left two steps, then up again one step, to the right one, up one. Then you reached your final destination. You can rearrange let's say the steps that you took in a different arrangement, but still you will be starting at here and ending at here. Let's see how is that possible. In that case, for example, I have rearranged my steps. Basically, I took that long step, I brought it to be the first step. The first one that I took is the long step to the left, which is two steps to the left. And then I delayed that one to be after it, which is in here, the second step. And then I continued the rest of the steps, this one and that one. And I brought this one back. So I just rearranged that steps, but like my resultant vector in both cases is exactly the same. Started at here, ended at here in both cases. So second property is telling you that you can add vectors in any order. How is that possible? Let's see. If I tell you that you move it, let's say 6 meters to the right, and then you stop, and then you moved again, let's say 4 meters to the right again, to the same direction. So both vectors have the same direction. So if you did not have this, you can write it as a note. We only can add vectors if they are at the same directions. And if they have the same directions, it's possible for us to add them. So as you can see, those two vectors have the same direction. Let's call this one vector A and this one vector B. So I can add them as I want. I can say A plus B, or I can say B plus A. So I can add them in any order. So this will give me the same result, which is 6 plus 4, which is 10 meters. Or what I did here is I said 6 plus 4 gave me 10. If I said 4 plus 6 is exactly the same, it's also 10, and I forgot the meters in here. The quantity is meter. Don't do what I did in the exam, you may get minus. Okay, now we go to the third property, which is to subtract a vector at its opposite. And that's basically reminding us of another note that I said in the class. Maybe you remember it if you are my student. We said that the condition for subtracting two vectors is that they must have an opposite directions. So in this case is to subtract a vector at its opposite. So it's just telling us that you have two vectors. One of them is going to the right, for example, the same 6 meters, but this time the 4 meters must go opposite, not the same. It's going where? Opposite to that direction. So when they are opposite directions, we can what? We can subtract them. So because this one is negative, I mean going to the left. So let's call this A and this one B again. This time we will have A minus B, the operation that we will have. Sorry. So to find the magnitude or the resultant magnitude, we will do the same. We will write the same formula. Summation of delta x will be delta x1 plus delta x2. But delta x2 has a negative sign, so when we substitute it in here, it will be 6 plus minus 4, which will give us 6 minus 4, which is 2. So that's basically the idea behind it. Now the last and very important, what is it called? Very important um, property. Very important property of the vectors, which is that if you have a vector, let's say the same 6 meters, you can either multiply it or divide it by a scalar. Why is that? Because the scalar is only a magnitude. So if I multiply 2 by a, the vector will be just doubled. It will be double. It will have the double magnitude that it has. So it has already 6. I mean, multiply the 6 by 2, we will have a magnitude of 12 meters for our new vector resultant. If we do the opposite now, if we divide our original vector by 2, we will get a shorter vector that is only 3 meters in length. So this is a very important aspect also, that the length of the arrow is specifying the magnitude of the vector quantity, which is something that we wrote in the lectures also. You can check it on your notebooks. So in the section 1, what we focused on studying is the introduction to vectors. So the questions of that section will focus mainly on the concept of the what is a vector. So as you can see in the question 1, the first question is asking you which of the following is a vector quantity and which is not, which is a scalar. So in here you need to keep in mind that the examples that we took are important to know, but normally the main ones that you need to know is the displacement. The main vectors that you need to know is like displacement, velocity, acceleration, and force. Those are the main four that you must know, that they are a vector quantities, adding to them the weight. So 5 that are important. And the rest, anything that you see a number, that's a scalar. But pay attention that this is a bit out of the curriculum, but like if you encounter this outside of the curriculum, make sure that the change in number is a vector, but the number itself is a scalar. So, for example, if we say that the temperature today is, let's say, 40, no, it's already gone, let's say 25 Celsius, and we are saying that this is the temperature for today, so that's a scalar. But if we said that the temperature went from 25 to 30, for example, the temperature raised up. So in that case, that's a change. So that's a vector quantity. Or went down, the same thing. So it have a direction, went up or down. So this is why we say the change is a vector quantity, but the number itself is a scalar. So you can see here in the first one, it mentioned an acceleration, so right away it's a vector. Then the number of passengers, that's scalar. The duration of the flight, those two are just numbers. So those two are scalars. Then the displacement, that's a vector. Then the amount of fuel required for the flight. So that's also a number. So then it's what? It's a scalar. No wonders with that. Okay. Then we come to a very important, I'm sorry, like not necessarily the opposite, directly the opposite. Not necessary question at all, which is how to graph a vectors. As you can see in here, a roller coaster moves 85 horizontally, so only a horizontal direction for the first vector, then traveled 45 meters at an angle of 30 above the horizon. So it's just giving you a two vectors, one of them is horizontal and the other one is with an angle. Of course, we did not study that yet, so such a question is a bit confusing. It's only asking you to solve it graphically, which is to graph the resultant, which is you started here, so you ended at here, and that's the whole thing, pretty much the whole thing that you need to do. And with that, we are done with the section 1. The rest of the questions of the section review is the same, which is like question 3 and 4. They are the same way, you just need to graph. Thank you, take care, and watch out for the section 2.